Hello everybody, I'm super happy to present you this video. I've been working on a POC, a proof of concept for a customer, and for a week, and I want to show you the result of the POC because it's a very interesting use case. Okay, so the customer's need is very simple. The customer wants to do machine learning with big files. The average size of files is something like 3 gigabytes. Okay. And then, after the calculation of the machine learning, the result should be sent to a database. Okay. So, in this architecture, the first OCI cloud service that we want to use is OCI Object Storage, a bucket, because this is the service to store very big files, as you see. Okay. In this service, each time we put a file in a bucket, we can emit an event. Then this event, okay, can be trapped by a rule. Okay. And we create a rule here. Each time we have an event object create in my compartment, in my bucket, I can then call a function. This function, called bucket sniffer, is here. And the goal of this function is to call an Argo workflow, because we decide to use Kubernetes cluster as a calculation cluster. And Argo Workflow is a very nice solution that could be used with machine learning. Actually, the customer is using script, Python script on-premise with big files on on-premise servers. And so we can put the script in a container or use just the script, and we can use it directly in Argo Workflow. It means that this product will transform our Kubernetes cluster into a calculation cluster with a very nice console in order to monitor, to administrate, and so on, and so on, and so on. And we have nothing to do with Kubernetes. And the nice thing is that with an OCI cluster, a Kubernetes cluster on OCI, we can use as many as VM as we want to run the pods. And so we have no limit of duration for the calculation, and we have no limit of CPU and memory to do the calculation. Okay? So this function will call an Argo workflow using REST API. If I'm looking to the REST API, you can see I can call the REST API of my Argo workflow cluster, and I give a JSON file to describe the workflow. Here you can see in the workflow, I will use an image, this image, okay. I did this image and I put it on OCI container registry. And this image can take a parameter, the name of the file, and can do the calculation. Okay? So very simple. Then at the end of the calculation, I will send the result to an Autonomous DB, and I will use two REST API. Here, directly, we can use a REST API with Soda on Autonomous DB to send the JSON result directly in an Autonomous JSON database. Okay? So let's go for the demonstration. In the first time, I'm going to upload 5 files to the bucket. Okay. So let's go. 5 different files. I'm using OCI CLI to upload the file in the bucket. You know, it's very fast. This part is for the 1 gigabyte file. As you see, OCI CLI is able to split the file into, for example, for the 3 gigabyte file, into 23 parts for a parallel upload. So it's very, very fast. After that, as you see, directly, we have some calculation on Argo Workflow, because if we are going to look at the rule, okay, we see that the rule is running, so an event was trapped, and the function here was called. Then the function called the Argo Workflow, okay, and the Argo Workflow is doing the calculation on the file, okay. If I'm looking here, I can see the result. I do a calculation of the demo file 1 gigabyte, and I calculate the total number of characters in the file, okay? And the duration of the calculation was 17 seconds. So very simple, very powerful. The last one is for the biggest file. So the biggest file, it's okay, the biggest file is finished, the 3 gigabyte file, and the calculation, okay, was done in 43 seconds, okay. If I'm going to Autonomous database, here, I have the calculation table. The calculation table here store the result in a JSON document, okay? And I can do a relational view of the JSON document. I did that with this view, G-calculation detail view. If I click here, I'm looking at the result directly. And so, as you see, it's a very, very nice architecture. First, if you fail to upload the file, then you can do it again. Okay, it's not a problem. After that, an event is trapped, a rule is running, and a function is called. If you have a problem, you can call the function if you want directly, or you can just call the workflow, because the only goal of the function is to call the workflow, and you can call the workflow yourself. Okay. If you have a problem after the calculation, then you will see all the logs here, so you are able to understand everything. Okay, it's very, very nice. And then, if you have a problem inserting the result in Autonomous DB, you can do an update later using directly the REST API on Autonomous DB. So how you see, it's a very, very strong solution, because you can send a lot of files to the bucket at the same time, and the customer need is something like the need is to send something like 3,000 files at the same time, so you can have a lot of calculation at the same time. Okay, you will use a Kubernetes cluster, and so worker nodes. A worker node it's a simple VM with CPU and memory, and you can have what you want about the number of CPU and memory. And when you are not doing calculation, you can turn off the VM in order to not pay for them and to not pay for the worker nodes. And so it's a very, very strong solution. As you see, you have no limit about the number of calculation. You have no limit about the duration. Here we see 59 seconds to read a 3 gigabyte file. But in fact, I'm not doing machine learning algorithm. And then the real time for the customer will be something with 20 minutes. And it's okay. You can run during 2 hours, 20 minutes, 3 days if you want. It's okay. And so this architecture is very, very powerful. This architecture can scale as you want. And so it's a very, very nice solution. I use Papertrail to get the log of the function. So it's another product on the market. Or we can use OCI logging. And so you are able to monitor everything, as you see. You can monitor everything, the rules, the function, the log of the function, the workflow, the calculation, and so on, and so on, and so on. So I have finished. Sure, really, I love this architecture, and that's why I did this video. I hope you will love it too. Okay, bye-bye.